A very cordial welcome to everybody who joins this meeting to the second virtual study tour within the biogas project DiBiCoo. It's a Horizon 2020 project funded by European Union. It's a project to bring technique providers and interested technicians from all over the world together to bring knowledge to the community in biogas technique and also, very important, to the new technique gasification. I'm very happy to welcome all of you, especially if it's morning or late evening. We are very thankful that you join in these special times from your side, and we are very happy to welcome our panelists who will reply to your questions. It's Marcel Huber from Synkraft and Bernhard Kirchmeier from Fröhling Company. Sorry, I couldn't reach the third panelist from the company Urbas. I hope he will join, but as we start with the company Synkraft, with the gasification plant in Dombian, may it's not a problem. We hope we can fix this within the time. We tried, or maybe at first, why do we have virtual study tour? Yeah, the reason is for everybody, I believe, well known. It's COVID. Because of travel restrictions, etc. We couldn't have those plant views directly at the plants. We couldn't show the plants, so we decided within a short period what could we do, and it came up the idea that we will have virtual study tours. So we made videos from 3 very interesting plants, and we tried to choose also, like we did for biogas technique, we tried also to choose 3 very different techniques and approaches to solve issues, etc. for these techniques, and they are very well properly running techniques. This is important because 10 years or maybe 15 years ago, but I sure believe it's about 10 years ago, there were several people or several technicians who didn't believe anymore on gasification. But now we have really well developed technique also in gasification, and it's very, very interesting to see these techniques working very properly. With today's, yes, this techniques were developed in the last few years by scientists and also by the companies, and we will start with the gasification plant in Dombian, Austria. It is a small village, but the technique is very interesting. And I would request Maya to show the first intro of Dombian. Maya, is it working? So, as Maya can't reply to reasons I don't know, I would like to go on.
Franz, I can try to do it.
Yes,
if you
do
want.
so, please do.
So
it doesn't work, or?
Can you see my screen?
Yes, but it's not running the
screen?
video. We see the screen, but not the video. The video is not running.
Okay. Now?
Yes.
Tons of wood chips annually. The gasification process produces around 500 tons of charcoal, which is used as a valuable humus fertilizer in agriculture. The electrical capacity of the system is 500 kilowatts, while the installed thermal capacity is 950 kilowatts. The waste heat from the process is fed into the connected local heating network, which is around 20 kilometers long and supplies surrounding households and businesses with renewable heat.
Thank you, Florian, for the intro. As requested during the advertising and registration process for this webinar, we kindly ask you, participants, to raise your questions via the chat function or by raising your hand. We really want to have you raising your question verbally. This would be the most appreciated way, so you could get in direct contact with Marcel Huber. He is the CEO and founder of Synkraft. Is there already a question? No. If not, so may I raise the first question, so being the icebreaker as usually. For me, it would be interesting, Marcel, if you could shortly explain in a few minutes why Synkraft decided to develop a double stage process for gasification. And the second question would be, why did you choose a way to produce also charcoal? Marcel, the floor would be yours. May you reply.
Thanks, Franz, for starting, and maybe I was the only one that was not really hearing the tone of the video, and maybe we have to flip a bit earlier in to get an idea what Synkraft is doing. So may someone give me the right to share a screen or to start over with this idea? That would be quite helpful, I think.
Yes, just one moment.
Thanks. Can you see this is our homepage? Can you see the homepage screen?
Just go on.
Okay.
Yes, fine.
So the basic idea of our process is to start on a what we say on a holistic approach, what we call a climate positive energy system. So what we're actually doing is we turn forest residues, what we later see, so to speak, wood chips that of a lower quality into in our power plants into power and heat and biochar, or replace local green gas by producing gas and biochar. And under development, we have this issue that we turn the wood chips into local hydrogen, heat and biochar. And the basic idea of this quite unique process is that beside the energy, we produce biochar, and biochar is concentrated, stable CO2 from the atmosphere. So based on this carbon neutral cycle of bioenergy in general, nevertheless, biogas or incineration of biomass, which is neutral as long as the fuel is grown sustainable, then we bypass a small amount of biochar. And this small amount of biochar in sum makes our process climate positive, or in other words, CO2 negative. I may now flip to the process itself, why it is maybe something a bit different. Is when I show you, and that was the question of Franz, as long as the dual connection is now working. But
maybe, Marcel, you explain a little bit the technique.
Yeah, that was the intention.
Panelist is not here. I believe we have time.
I just have to wait always for the presentation, because so now I think what we are having here is a quite unique process setup, which is indeed, as you mentioned, Franz, a staged gasification process. So there are deep basics when it's up to thermochemical conversation. The first thing you have to do, which is not shown on this graph, is you have to dry the fuel. Only dry fuel is burning. And the first stage in converting biomass into gas is the pyrolysis step. So whenever you talk about pyrolysis, it's not to be mismatched with gasification because it's totally different process. It's like baking biomass and turning woody biomass into charcoal. This is pyrolysis. And after this pyrolysis, we have this pyrolysis gas, which is not called the syngas, but we have this pyrolysis gas and the charcoal. And the term gasification is related to the stage where you turn this carbon, this biochar, this charcoal, into gas by means of a gasification agent. So whenever you talk about gasification or biomass gasification, you mean both steps. So when we started our business in 2009, for us it was vital, as biomass gasification is a complex process, to separate both steps that are so different. And so we ended up in a pyrolysis unit that turns the wood chips into biochar and pyrolysis gas, which also contains the tar. And we simply burn the tar before the gasification stage to get the energy to gasify the charcoal. So what is the key of this process is that gasification is done one step after the other. And this ensures a very high gas quality and a very high char quality. And so we are enabled to operate engines of the state of the art, which in our case come only from Inyo, Jembacher, and 2G. So these engines are 4-valve technologies, turbocharged at more than 2 bars, double-staged intercooled. So with this setup, you achieve this round about 30% total overall efficiency, and as a byproduct, valuable biochar, which is not contaminated, but pure. And that is the idea of this maybe more complex process, but for sure more precise process when it comes to thermochemical conversation. I don't know, Franz, whether this answers the question, but
yes, maybe the next question is, how do you steer the degradation of charcoal in the second step, meaning producing more charcoal, running the process, having a little bit less gas, wood gas, or having a little bit more wood gas, and then the opposite, having a little bit more charcoal or less charcoal? Can you steer this, and how will you do it?
Yeah, of course, it's always about how much air or process or gasification agent you add. So we have a freedom to operate on let's say on a nominal capacity and increase the output of biochar, while keeping the energy system on the same capacity level. Of course, also the system itself, it's part loadable and so on. So this is what we say standard, but so we can reduce the power level of our plant down to 60%, but this is not common practice because our systems are understood as baseload heat and power supply units. So modulating them is maybe in general, when it comes to gasification plants, which is totally different to biogas plants, but with gasification plants, not the best idea, at least for us. But of course, we can at current stage with the small plants, starting from 200 kilowatt electric, we can almost double the output of biochar by keeping the power output on a nominal level.
sorry, I have to unmute. And how can you steer or keep the floating in the second stage? This is a very difficult process, I believe, to keep the charcoal in a floating area so it will kept and there will be no breakthrough of unburned or undegraded pyrolysis gas.
I can show you a short video how this floating fixed bed up is working, because our second stage is also the reason for our special design. I now try to switch to presentation where it's more reflected. So you can see my presentation now.
Yes, we can see it.
So this is the idea of our tar elimination. It's just burning the tar. So there's no tar cracking, no tar precipitation or whatever. Tar is a perfect fuel, so we just burn it to get the heat for the second stage, and that leads to a clean condensate and to a clean flame. And in the same reason is our floating fixed bed able to auto distribute particle sizes. So while the coarse particles stay at the bottom, the fine particles, the already gasified particles, went to the upper, more wide section. So that's why we can deal also with bark and also with not so clean fuels, and we can also deal with fines because of this special behavior of our floating fixed bed. And so that you get an idea, I mean, this video is a cold model video because you can't see inside the hot gasifier. This has been taken in 2007, and here you can see how, if you know how this floating fixed bed behaves. So you see it here in the cold model with oak flakes, and it's like a fixed bed hovering on the tar burner, more or less. And by allowing this process, you don't have any breakthroughs of tars, because you have a very turbulent zone at the bottom where you can ensure to burn 99.9% of all the tars before entering the gasifier or the reduction or gasification zone. So by operating this unique and patented system that enables us to have this clean gas, the clean char, and to be maximum of fuel flexibility. So it's all in this unique design. And when we talk about fuel, we don't talk about waste or dirt things. It's still, we need wood chips. I mean, this is important to note. This is not a compost or shredded material or whatever. So there is a certain fuel quality needed to ensure a proper operation of the engines. But we say we can accept low quality wood chips, and that's what it looks like in real, to get a better quality understanding.
So we have at the moment, Marcel, already a few questions coming in. May Esther Quist Thurson, you could raise your question by yourself. Is it possible for you? Can you unmute yourself? It doesn't work. So I will raise the question and I read it. What customer topography do the plants provide its heat and power to, and what is the percentage distribution of the different customer groups? For instance, residential, for example, residential business, heavy industry, cottage industries, etc.
I think it's very important that that our plants start at a certain size only. So the smallest plant we actually provide is what we call the 200 plus plant, which is more or less as a
Marcel, you have to divide between electricity and heat or input energy. So to make this clear, 200, I believe you mean kilowatt electricity output. Is this right?
Exactly. I just shared a screen with the overview.
Okay.
So this is. Can you see it on the page? Yes. This is our smallest plant. It provides 200 kilowatt electric. We call it plus because it works up to 250, 260, depends on the setup. This is the thermal output at 90%, so we can also get low temperature heat by heat reclamation of exhaust gases. This is the range of fuel capacity. Here you see also the space requirements and so on. So, but nevertheless, even the smallest one is nothing for households. I would even doubt that it's something for small farms. It starts always with some kind of municipality, service company, or local energy provider, because we're talking about several gigawatt hours of power and heat to be distributed. So we talk about here, it's about two gigawatt hours. This is what we say our flagship is on the right side. So these are the bigger plants. We are currently building 13 of these in parallel, and only the 500 kilowatt units or the 1 megawatt, which is a combination of two gasifiers with one engine. And they provide about 10 gigawatt hours of energy per year. So this is nothing for a small surrounding or whatever. You always need some industry, some big food processors or something else in the background to give a year-round purpose for the energy.
So thank you for that. The second question comes from Dominic Rutz. May Dominic, you can raise your question by yourself. Is it possible, please? Sadly, sorry for that. So I raised the question. It's a question about for the operators, but in that case, you will kindly reply to it. Which concepts do you have for the European summer, or it's everywhere the same? In one part of the year, you may have summer besides the equatorial areas, etc. There's only very little demand for heat in summer. Do you reduce the capacity or switch off some of the generators? This is would be also interesting for the target country, and it may be in total. There's often very little need for heat.
Yeah, that's what I've meant with process factories in the background, because the grid for households indeed has in summer quite a little demand, but the belief that there in general is no need for heat in summer, that is a big underestimate of the situation, I think. What we provide is a baseload heat supply system beside the power. So we believe that in district heating grids, and for sure grids will be necessary to collect and share heat demand and supply issues on a local network, they always need a certain amount of power. And the bigger they are, the more baseload they have. And if you look to Denmark or to those who have really applied big heating grids, you know that there is a summer load. This summer load can be no more better done by us or others, but in the baseload. So the idea is not to switch off in March or April. Maybe in in the long vision, we have to talk about July and August. That's for sure. But our plants also, and we're currently building 4 megawatts, planning 4 megawatts in Germany. That will only operate about the 6,500 to 7,000 hours. So they are turned off in hot season. But this has to develop, I think.
Yes, thank you. And maybe to talk only to finish this, the most gasification plants are connected to district heating facilities where it's not possible because no heat for district heating is needed. May you suited such a wood gas plant directly to factories where they really need heat. Otherwise, you have to shut down, and this is very important also for this process. You can shut down the process and restart it later on. So maybe for this you have lower full load hours per year, but you can run it always, stop it and reintroduce it or restart the process. This is important. The next question was raised by Johannes Anwan. Johannes, could you try to raise your question or speak your question by yourself? Can you unmute you?
Yeah, can you hear me, Franz?
Yeah.
If you not?
Yes, I can hear you. Please go on.
Okay, perfect. Thank you very much, Marcel, for the introduction. We also saw the video that was produced from the project. My question goes in a similar direction than the previous one, looking at your business model. So I would like to know a little bit more about the business model of your income generation. So you have heat, you have power, you have the charcoal fertilizer, but then you have also the Störstoffe that you actually have to treat somewhere. Can you give us an estimation or percentage of your income generated at that plant that was depicted in the video? To what percentage heat, electricity, and the charcoal revenue actually goes into your business? That would be great. Thank you.
Yeah, thanks, Johannes, for the question. That's a very good one. We are building power plants. So the main income is through power, means electricity. And that's about, 2/3, I would say. That's not only with the plant you have seen, which is connected to district heating. And as Franz said, all of our systems are more or less connected to a district heating plant, except the one in Japan, I have to admit. But this is a different story. In the past, the third quarter, or the third third was heat. So normally our plants are located quite closely to the district heating grid. So we're only talking about a few miles with several gigawatt hours of heat, which is very efficient. And the charcoal has already is competitive, about the second place in the income with the heat. So more or less from past to now, there's another third of income by the biochar only. So this is no more a nice idea. This is really what we say a third pillar of our economic systems. You have to understand that our plants do not even only get for the biochar as a raw material itself paid, and not badly, especially the plant you have seen. You get carbon credits already. So not by theory, but practically paid. And it's all on the incentive market, but as you might have recognized, the CO2 incentive market has overrun the CO2 market by law, so to speak, and overthrown. this is really a game changer and tends towards a total different business model where you have 4 income streams. You have the power as a base load, you have the heat as a minor issue, and we have the charcoal together with the carbon credits. And so the plants really turn out, especially the bigger size, they can cope with quite low feed-in tariffs, or with lower feed-in tariffs, and are still quite profitable. So for our customers, just to mention, we don't have any of our plants is run by our own.
Johannes, may you have raised a second question. May you could raise it directly here.
Yeah,
And
thank you. Thank you very much. Marcel, thanks for the answer as well. I think that covers well what particularly our project partner countries usually have as a, let's say, a not so favorable economic environment, in a way that gate tariffs or subsidies are not broadly available. So it's very important to hear that the market for charcoal is not just based on the subsidies, but the CO2 market is really uptaking, and that's also that it's available globally. I think it's a very important message, because if we only talk about electricity, it's always the tariff fee that makes this plants profitable or not, and that might differ from region, country to country, depending on the local energy market. So maybe you can add a little bit to that in terms of the profitable examples that you have where the economic gate fee or subsidy system is different from, let's say, Europe. I think that would be particularly interesting for our guests from developing or emerging countries. And the second question I would have is on the Störstoffe. I don't know exactly the English term, so the more or less impurities
stones,
that you have
stones and nails.
Okay, so it's basically stones and nails. That's good. So you don't have to treat them. So the question would be, is it Sondermüll, or is it something that you have to treat very difficultly? You have to pay for getting it off your plant side. Maybe a word on that as well. Thank you.
Yeah, the impurities are stones and nails, and some minor pieces that might slag or agglomerate from sands. So it's really nothing that should be in, but in real is in. So we have a defined exit for those things without stopping the process. And if you have to understand that the charcoal is a light substance which floats quite easily, so a lower particle density, and stones and nails do not float. So this is a more or less a Windsichter or something, a gravity or mass, a separation system where we can easily extract stones and nails before they enter the hot zone, which is quite a big advantage for our system, by the way. And the fuel we operate our plants, or the customers operate our plants, they contain a lot of these things. So most of the time more than we want, but this is an optimization process of our customers. So I can't tell you how they are contaminated, because they are not contaminated, and the mass is what goes in, goes out. Normally it's a container.
A little bit quicker, Marcel.
Okay, it's what in goes out, so the mass, but it doesn't has any big issue. And concerning the tariffs and those issues, we have plants in Croatia operating that have no tariff, so they are self-supplied, now working for more than 10,000 hours already. We have plants in Germany on the run that operate on this, I don't know, 16, 17 euro cents. That's enough if you deal with the carbon credits and so on, makes a workable project. But of course, we also have, especially the smaller plants, they need a good feed-in tariff still. So not far from 20. Yeah, so this is very important.
Thanks.
If the-
There is
Sorry.
one question from Sulaiman Ismail, but this refers to anaerobic digestion. So, Sulaiman, may you raise your question, but I sure believe this is a question for another webinar. This belongs directly to biogas technique, but not for gasification. May you unmute yourself? If it doesn't work, may you send me an email and we could go in interaction directly to reply to your question. Why does your biogas technique not start? This would be better because we deal in this webinar with gasification and not biogas technique. So the next question was raised by Hannah. Sorry, I lost it. Hannah Fadila, may you could raise your question personally? Could you unmute? Does it work? If not, I will read it. She has several questions referring to the characteristics of the wood chips of biomass and some of the gasification plant mechanism. So moisture content for the wood chips and which are used for pyrolysis, pre-drying process, the calorific value of the biomass, and the calorific value of the wood gas. This is important.
Moisture content at site doesn't matter because pre-drying is always with our systems. The fuel must not enter the plant above 10% water content. So we force customers to do it less than 10. It is controlled and monitored so the plant recognizes whether it's in or out. So this is very important, and I recommend for all gasification systems because wet chips can't be pyrolyzed. The water has to go out first every time. So it doesn't make sense to gasify wet chips. That's my thermochemical understanding. Second is the minimum heating value of the fuel is 4 kilowatt hours per kilogram. Yeah, right. So normally it's about 5. So we can accept a bit lower heating value. The ash melting temperature must be of the fuel must be around 1000 degrees Celsius, not far below. So if you have cereals, crops, whatever, it contains potassium, it's not going to work with us, and it's not worth a trial. So we have to have these ash melting temperatures above 1000 degrees. And the heating value of our synthesis gas, wood gas, is 1.5 to 1.6 kilowatt hours per standard cubic meter. And the main driver, the main energy content of our wood gas is hydrogen. So it's about 45%, which is not standard. Normally you have the carbon monoxide dominating. As we try to stay low in temperature, which is the slagging issue, the hydrogen is dominating. And that's good because that gives a good drive for the gas.
And there was one remaining question, the pressure for the, I believe for the, it is written down for the combustion, but I believe it's the pressure you use in the gasification process.
We have an overpressure system, which is also quite unique. So the plant is run below 500 millibars. That is what we understand on the only way to make it really safe operation, because otherwise you have to monitor oxygen and the gas safely, which is quite a big job. But it's 200, 300 millibars, so not a big issue. Yeah.
So and there's a next question from Dominic Rutz, and he says he can unmute himself. So Dominic, please raise your question.
Yeah, do you hear me now?
Yes.
Ah, great. Okay, very good. So first of all, many thanks also for the 3 videos. They are really excellent. My question goes into the direction what Johannes was asking, because like the last time I visited some gasification plants was around 3-4 years ago in Germany, and there was always the issue that it was quite uncertain what to do with the char because of legislation. It was different processes than that for Synkraft. So my question to you would be for Synkraft, is it really, let's say, true that there is no residues or waste that you would have to pay to get rid of, either char or any ashes or whatsoever? Thank you.
I mean, yeah, thanks, Dominic, for the question. Except these stones and nails or impurities, you have to dispose. So they are waste and they have a number, just to make that clear. But the amount is very small. But there is no char at any of our plants that has to be disposed. That is very important. And it's not about it's not about a price. So all our plants get paid for the biochar, and the price starts on the raw material at the 200 euro per ton, which is not that big, but the upper end is far off the 200. So and especially the plant you have seen, they make a good value out of the biochar.
Okay. Thank you very much for this answer. And just one note on that. I think that's a reason why it is or could be very interesting, especially for our target countries, because then the char or charcoal could be really like acting as a carbon sink on the one side, and on the other side as a soil improver, and that is an additional added value that somehow needs to be promoted in those countries.
I think it is a proven biogas boost system or a buffer that works for oil or sugar-based ingredients you put into a biogas plant. So it works as an adsorbent. And the reason is we have the stage process, and due to the stage process, we have a clean gas, and the clean gas leads to clean char. And that is the missing link. So if you have tar in your gas, you have tar on your char. And if you have tar on your char, the value is lost by the contamination. And that is what we have been started without this hurdle. And that's why we are proud of our biochar and see it as a third product. In fact, most of the gasification systems produce char. Not
one
ash.
remaining question, Marcel. Please quick, because we have a second participant who also wants to reply to the question. Is your biochar certified by, I believe, EBC is European Biochar Certification System? Yes.
Yes.
May you?
It's even more. It has almost everything you can have. It's REACH. It's GMP plus, it's EPC, it's whatever, but I think it is very important that the plant itself produces a quite homogeneous raw material, and certifying is always an additional work. So for example, if you produce feed char, you have to be sure not having any stone or nail inside. So it's possible, but it's additional work to get these certifications.
So, thanks for that. We have 2 hands raised. One is from Julio Menendez. Could you unmute yourself, Julio, and raise your question? Does it work?
Yes.
Yes, I can hear you.
I actually sent the question, and it was, please let me know more about the details on the carbon market or certification that you can access with this technology. You mentioned already something. applying to soil? Do you have experiences on the voluntary carbon market or what we call natural-based solutions? How do you see the charcoal and the technology on this side? Then I have two more.
I don't see the fertilizer or soil application as a good market, because the value in Europe is not that good, because soils are not that bad. So biochar improves soil, especially in acidic soils, by pH control. But I love these usages of in feed char, or where there is a far bigger impact of the sorbent characteristics of the biochar. I can just give you the name Carbon Future, which is the trading platform developed in Germany that deals most of our carbon credits, or the carbon credits of our customers. It's carbonfuture.earth. It's a great company that also collaborates now with Climeworks, as far as I've understood it. So these handle all these carbon credits, and they are worth €100 per ton of CO2 in real now, and increasing. So this is.
Is the question answered, Julio?
Yes. Thanks a lot, and I will look forward for this. Another question is, sorry if I missed it at the beginning, but related to the capex and opex for the two extremes scales, we will say. And then I have one remaining one regarding to your post sales and spare parts supply for South America, if you have some experience or if you are coming into this market or not. There are two questions combined.
Thanks, Julio, for the question. I think about the idea of entering the market in Southern America, we have to do a private talk. And but of course, we have now built a plant also in Japan. So far away countries need special frameworks to be successful. The capex, I can give you a rough number, starts at €4,000 per kilowatt electric, installed and commissioned, for the big plants, and of course higher with the smaller plants, but these details we also spare for a later issue. And yeah, we are setting up actually quite a good after sales team. We are building at the moment 6.5 megawatts. We have built another 5, so it's a reasonable size already. So we're doing our 29th plant. It's no more.
Marcel, we have to go on. Sorry for interrupting. We will do it another way around. Please, sorry for that. I apologize for that. But if there is a further question, Julio, please send it to us via DiBiCoo, and we will directly forward it to Marcel, and you can go in direct interaction. This would
Thank
be
you
the
very
best
much.
way, I believe.
Thanks a lot for your presentation and answers. Thanks.
Thank you. There's one remaining flag, and it's Muhammad Kismuntono. Maybe can you unmute yourself? Doesn't it work? Sorry, if it doesn't work, we have to go on. Sorry for that. Apologize again for the technical issues we face. Please, for remaining questions, sure, raise them, write us via DiBiCoo. You have the email address, info@dibicoo.org, and raise your question or send it directly to me. It's my family name, Kirchmeier at compost-biogas.info, and we will sample this question, forward it to the participants or to the panelists, and so you can be sure that your questions will be answered. Sure, we want to be and to stay in interaction with you. We will go on to the second plant. It's the plant in Scheibs, also in Austria. It's a complete different approach, but also very interesting approach. And Maya, could you please show the intro of this plant?
I will do it again, friends.
Thank you, Florian.
So can you see my screen now?
Yes, I can see it.
The gasification plant in Scheibs deals with about 6,000 tons of wood chips per year.
Can you raise up the volume?
Yes.
While the installed thermal capacity is 3 megawatts. Due to its 6 kilometer long grid of district heating pipes, more than 170 households are supplied with renewable heat energy.
So thank you for the intro. And I believe I have to lower the flags which are still raised. Are there already some questions here within the chat function? No, if not, Bernard, great thanks to you that you participate. Bernard Kirchmeier is
Thank you for your chance.
Yes. May you introduce yourself a little bit and then come to the first question. What were the greatest obstacles for the developing of the process you choose? And the second question is, why did you choose the size, the special size of 50 kilowatt electricity, and how could you make it possible that your gasifier is such small in compared to the output? Please, Bernard.
Okay, thank you all. May me introduce myself. So I'm Bernard Kirchmeier. I'm working for the Fröhling company. We are manufacturers of biomass systems, from small plants for district heating and also for the household plants. And we are even working on this gasification since some years. And may I introduce you also our company, that you can see a little bit what we are working. And then, so can you see now my?
We can see it, yes.
Okay, so that's the gasification. Sorry, that's the wrong. Still not working here. Okay. So this is our company. We are in Upper Austria and working with all these products for wood, heating of wood. We are about 600 employees in whole Europe, and we are also making these logwood boilers, pellets boilers, dual fuel boilers, wood chips, and also miscanthus boilers. We have big plants and big boiler plants for the industrial boiler sizes, and even are working on these fixed bed gasifying units. We call them also CHP. That's the name for combined heat and power. The name or the question from Franz was what our goal is. We wanted to come into the market with a smaller, very compact possibility, with a machine which also is automatically driven for these district heating systems, where the heat output can also be sold into the grid, and not only the electricity is the main goal, even also the calorific value is important. Our electrical and thermal output is much lower than we have heard before. The thermal output is about 110 kilowatts thermal power, and we have the electrical output of 56 kilowatt electrical. Yeah. And so it was our goal to make it also very efficient from the overall efficiency, to take out the best possibility from the wood chips, and have also a really high electrical output. We have these gasifying units in containerized version, and also have this in in-house plants. So you have seen it in the videos, and just to show you, we have this also for export markets, interesting in completely containerized plants, or even built into energy plants inside. So you can see here some possibilities where you also can find a cascade, these units that you can make 1, 2, 3, or 4 units in one room, and so you have really good possibility to let the machines on the grid and run for the electricity. Yeah.
Thank you for the introduction, Bernard. One remaining question at the beginning. Your gasifier is really such small compared to the output.
Yes.
Could you explain how did you solve it so that the gasifier is such small?
We realized that the problem is also for the plants to have big heating plants, and it was our goal to define this pyrolysis reformer in a very compact way. So it is from our history that we can design all these components ourselves, and make also the control system for this. And this was the idea, to make it very compact, even to come into containerized versions, and also to get it into heating plants very well, and to make it cascading. Yeah, so it's also possible for, if for example you have four plants, you can even let 3 working if you have a revision on one unit. And so it was the idea to make it so compact, to have the reformer and also the gas cooler and the gas filter in a very compact unit, so that we can optimize the reforming, that the pyrolysis in this gasifying unit. And yeah, this was happily going on.
May you explain a little bit for the auditorium, how do you start the process? If you have a standstill and now start again, or completely start it at the beginning, how do you do it?
So it starts like you can see here in the schematic. This is the working principle. We're starting bringing in the wood chips that are even processed and brought in to the reformer with screws. So with the screws, we have also the filling into reformer, and in this reformer there starts the drying and the pyrolysis of the dry wood chips. Yeah, and you see the side channel blower. With this, we bring to a small point an oxidation unit where no flame exists. And with the reduction zone in the reformer, we generate this product gas. You see then there is starting after the starting of the gasification unit, we can flare this up. That means until the quality of the wood gas is clean enough and has enough pressure and has enough quality to start the engine. Before that, this can be started automatically from cold up to 15 minutes. There is a flare process, and so this wood gas, before starting the motor with it, is being flared up, and after this the gas is in a good quality. Then we go through the gas cooling process and then through a filter where we then drive the 6-cylinder MAN engine which drives the generator. So this process can be started automatically. And the very good goal of it is that we can modulate it even. So with all these screws and the gas amount, we can modulate down to half of the electricity output if it's necessary. Most customers will run it on full power, of course, to create the most efficiency, the most electrical output. But it's also possible, for example, if you have not the possibility to sell the energy at the moment, then you can modulate it down if you don't have the possibility to have the thermal output, making it into the grid or into the net.
You inertize the gasifier at the moment you stop it or before start it. How do you do this?
Sorry, the
inertisieren mit Stickstoff.
Yes, so we started with the side channel blower, and we have an automatic ignition system on this part, so it's tightened. So we have overpressure in this process also, and it's tightened with the fuel locks, and everything is tightened with air flaps. So the values and the valves are driven pneumatically.
So the Suleiman Ismail already raised the question. May Suleiman, you can unmute yourself. It should work and raise your question. Yes, it should work. Please raise your question. We can't hear you. May you have unmuted your audio system, because our system shows that you could speak. Sorry, we can't hear you. Could you write down your question? Would this be possible in the chat or in the question function? Sorry, we still can't hear you. We see your micro green, but sure we can't hear you. It should be a problem with your audio device, with our headset, with your headset, etc. Maybe please try to write down your question, because we really want to, and Bernard really wants to reply to it. There's another question coming from Charles Bartels. May you can unmute and raise your question. Yes.
Yeah.
If I see the question from.
Can you hear me? This is Charles.
We can hear you, Charles. Please raise your
Good
question.
afternoon. A nice presentation to you. I'm talking from Ghana, and I want to know the total cost of the plants, like the household, and maybe for a community of about 25 households. Yeah, and my second question is, why do you not use palm kernel shells? Because over here it's in abundance and it's totally waste in our part of the world.
Okay, I did not hear the question. What material, which fuel do you want to use?
Yeah.
Could
Hello?
you please
Am
explain?
I clear?
Please explain which feedstock you have, which material.
Palm
Which
kernel
fuel
shells. Palm kernel shells. You know
Okay,
palm kernel
shells.
shells? Yeah, the palm kernel after using maybe the one they used to do the red oil. The fruit, the palm kernel, the fruit that they used to do the red oil. After extracting the red oil, the nuts.
From the palm oil.
Yes,
kernels.
the nuts.
Palm oil.
The nut. I'm talking about the nut. The nut goes to waste over here.
The kern.
After extraction, yes. So why
Yes,
don't
okay.
you use that? And I know that in finances they use in especially finances they use, and the heating rate is so high it can sustain much heat too. That is
Yes.
what I know of it is.
Okay. Honestly, we still don't have much experience on this fuel on gasification process. We have already tested some nuts and also oil devices. Like in Spain, we have burned them in classic boilers, and we know that the oil inside this fuel has a very high calorific value. So it will be able to burn it in a boiler. But honestly, our company still not has the experience on the gasification with these fuels. We are here in Austria and use wood chips from trees, from wood, and I think the high calorific value and also the oil, the residential oil in your shells may have some chemical issues during the gasification, because now with wood chips we have also very high temperature inside the reformer part. Maybe even the ash content, it must be analyzed what the ash content is and where is the ashing melt of this fuel, and then we could have a look how this would work in a reformer gasification process.
Maybe could solve it in that way, Charles. Could you send us analysis from your palm kernels and may send to us, and we forward it to Bernard, and if it shows that they want to try it, if they can do it, try to gasify it, and then you could go on forward and send sample materials to Fröhling. This could also be done. This is done by many manufacturers, and this is a possible way to start the process and try. Could this be possible? Send first analysis of the material you have, and the second step, if they say, okay, we will try it, go and send a sample.
Yeah, I'll be more than happy to assist. But what you can do is that give me the parameters, and I'll try to work on that. The parameters that you want to be satisfied in the test.
No, it's vice versa. You should have sent the analysis.
The calorific value, the ash melting point, and the heat content. That is and also the chemical substances, like the chemical analysis. Yeah.
Okay. Okay. I'll get back to you if I have any question. Yes, I'll get back to you.
Thank you.
Thank you.
Thank you. Thank you.
Still, Suleiman has raised his hand. Suleiman, can you unmute now? Please try to speak. But again, we can't hear you. Sorry for that. We can hear background noise, but not anything else. I see in the chat function, you raised the question about creating biogas from animal dung. And this is sure a question for a biogas system, but not for gasification system, because in gasification you have high amounts of nitrogen then in the gas, and additionally, because of potassium, phosphorus, etc., you may have problems with the ash melting point. So it's not a typical question for gasification. It's much more a question for biogas systems. Please, if you have a special question on that, raise your question within the DiBiCoo email function, and we will answer it there. And if essential, and we can't answer it, we will forward it to the specialists from the universities. So we have raised questions from Ivan. Yes, please raise your question.
Thank you very much. My name is Hammond. Can you hear me?
Yes.
Yes, we can hear you.
Okay, thank you very much. I'm speaking from Ghana. Please, I want to know the amortization period. Like, if I buy this equipment to produce electricity for a community, how long will it take me to pay back my investment?
That's a difficult question, because that is depending on your parameters, how you can sell heat and electricity. So
which price?
From our side, which price you have for electricity, and also which price you can generate selling the heat. So from our side, from the manufacturer side, this is difficult to answer, because we can help you to find which costs you have to run the plant, but we do not know which prices you can generate on selling electricity into the grid in your country, or selling the heat in your country. That is always depending on the countries, and even on the point the plant is installed.
Okay, thank you very much. Like, taking your own country, for instance, how long did it take you people to? I believe this equipment has been experimented. So
Yes.
how long did it take, like, any company that purchased this equipment to produce
So
electricity?
Normally, if the electricity is sold to the official grid, and also the thermal heat is sold and put into the grid, normally you can calculate with 10 to 15 years.
Oh, okay. Because what I know is that most of paper that I've read, or publications, mostly shows that the cost involved in the gasification process, torrefaction process, pyrolysis process is higher than the energy yield of all these thermochemical processes. So I actually work on one of these thermochemical processes. So, and I've been trying to go into like kind of a small scale business with the one that I fabricated. But the cost involved, when I did the analysis, I realized that the energy that I used to gasify my raw materials is higher than what I'm getting from the gasification process. I don't know whether you have experienced that in your case.
So our experience is that if you only use your fuel in a biomass boiler, yeah, you have more efficiency output, because there, if you burn it completely, you have the complete oxidation of your fuel, then you're on efficiency more than 92, 93%. In this case of the gasification, of course, because of the process itself, the total efficiency amount is lower than 90%. So you must also calculate more maintenance than on a boiler, for example.
Oh, okay, thank you very much. The last thing is that I would want to know the software that you use for your schematic diagram.
Which software we have used?
Yes, to draw this schematic diagram.
Okay, that's drawn on Corel Draw. That's easy. Just call it Corel Draw Schematic.
Okay, okay, all right. Thank you very much.
You're welcome.
Thanks for your question. The next question came from Enoch Egipong. Enoch, may you could unmute? Yes. Raise your question,
Okay,
please.
Greetings, Enoch Ejepong from the Renewable Energy Association of Ghana. Thanks for your presentation. What intrigues me are two questions I have. One on local material or raw material that can be used in producing the gasifiers you have and the entire value chain around it. Usually, I'm asking because usually there's always the question of trying to have local content and particularly being able to have raw material from the local side to be able to use for some of these. So if there's a project that would happen, I'm just trying to see the kind of raw material that is the resources that will be required in that state to be able to do such assembly or manufacturing here, and the technology transfer process. That's one. The second question has to do with the feedstock fuel. I earlier heard about the palm kernel and all, but I'm not sure whether your system is able to take combined material and what it's not able to take. So if you can speak to that briefly, I'd be appreciative of it. Thank you.
Thank you for your question. So I will start with the second question. We have the experience in a homogenic fuel system. That means that our wood chips from the trees, from waste woods, also without nails and stones. And if the characteristics of your fuels may be similar to wood chips, then it will be possible. And that's the same question or the same answer we had before. We should make a material analysis to see what are the chemical components of your fuel. Yeah.
Right. Okay, that's understood on that one.
Thanks for your question. And there's a remaining question from Suleiman again. Suleiman, try again. You need to unmute yourself, Suleiman. Please raise your question. Sorry, we can't hear you. Your micro should work, but we can't hear you. Sorry, I read in the chat that this is saying thank you. Thanks also to you for joining, but without a question, we can't reply to it. And we want to go back to Enoch. He has a question again. He raised again his hand. Maybe Enoch.
Yeah, I think the first part of my question was not answered. I was looking at material with regards to construction.
Again?
Sorry, we did not understand your question. No, sorry, not really. Can you explain your question?
I was asking that in terms of the equipment that you have manufactured for the pyrolysis process and all the gasification, if it's supposed to be built here in Ghana, I'm just trying to confirm if it would mean transporting all material from abroad here, or whether some components and material buildup can be made here, and so you can have a bit of local context. And I'm asking about the issues around technology transfer.
Yeah, now I understand. So the system, as you can see, is functioning together. So in the gasifying unit and also the CHP unit, the engine with the generator. So to getting it in your country, it would be the easiest way to make a containerized version, as we have also put it to Great Britain or other countries, where this unit is already pre-assembled and also pre-commissioned. That means this plant is set up and also started in our company first, and then there would be the possibility to transfer all the components to your country. what is possible that you can make is just the fuel storage, yeah. But all the technology from fuel feeding system, the screws, the augers, the filling system is all made from our side, because the control is made for an automatic driving of this unit, and it's also designed for automatic running this unit.
Okay, so meaning that also with regards to operations and maintenance, it's almost reduced in terms of how much human intervention you can have.
So in realistic, then the maintenance guys which are on site are trained from our side, and it is our goal that you know all the parameters, all the points to drive this plant by yourself. Yeah.
Right. Okay. Thank you. Noted.
Thank you. Welcome.
So thanks also to this last question, and thanks to Bernard. I have no further questions here at the moment. Hopefully we could reply to all raised questions. Let me say, at least again, apologize for the technical issues we had. It was the first time we experienced this, so we couldn't really figure out why this happened. I hope it went also. Some points were not good enough. It went well for you. Thanks for joining. And at last, I want to say again the contact details. It's contact@dibicoo.org is the email address. We have launched the website DiBiCoo.org, and there's a biogas and gasification platform for the manufacturer where you can directly get in contact to them. And this platform is biogasplatform.eu. So let's have a look at our website from the project, have a look at our matchmaking platform, biogasplatform.eu, or just write us an email and we got directly to you and reply to it. We are replying to you. Thanks for joining the webinar. Thanks especially to Marcel and Bernard for being available to introduce their technique, making this great job, bringing this technique, also this technique faced about centuries, very difficulties, and bring it at least to such a good technique, which is really operating nearly above 8,000 full load hours per year. And this is magnificent. No, I can say it. It is very wonderful. Thanks everybody for joining. Have a nice day. If questions still not answered, please raise it via the email on dibicoo.org. Have a nice day. Bye.
Thank you. Welcome. Bye-bye.
Thank you. Bye.